All right, welcome to our lesson today on the slope-intercept form. So for today's lesson, it'll be pretty straightforward. We'll try to find the slope-intercept form of a given graph of a linear relation, and then we'll go backwards where we are given a slope-intercept form, and we'll go backwards to make the linear function. All right, so this graph right here may look familiar to some of you because we actually covered it in our linear relations lesson, where we have the car rental cost, right, of like a random company, and we have the distance in kilometers traveled against the cost of this car rental, right? So if we were to start at 0 kilometers, we have to pay $60, which means that to rent this car before we even drive it, we have to pay a $60 upfront fee. After 100 kilometers, we get to $80. 200, we get to, what is that? That's 100, right? So we can see that this is a linear relation because it is a completely straight line, right? And we also found that the formula for this relation is this fella right here. And our lesson today is to dissect what this formula is actually telling us, right? So starting off, like I mentioned earlier, if we were to start at 0 kilometers, right, our cost will start at $60. And we also know that the y-intercept is when our graph touches the y-axis. In this case, this point right here. And which means that the coordinate of this point is 0, 60. And in order for our graph to touch the y-axis, our x must be at 0, right? As you can see right here. Which means that our y-intercept is 60 on this graph. Okay, how about the slope now? What is the slope of our graph? Okay, so using what we learned from our last lesson on slope of a line, we take 2 points and figure out how much the x and y values are changing. Right, so let's do it in green here. Let's just take this point and this point. Right, so how much of the x and y value are those 2 points changing? So let's see. We are going to the right by 2 and then going up by 1. Right, and the slope is the change in y over change in x, the rise over run. So our slope would just be 1 over 2. Right, except it's not quite. Right, it is 1 over 2 if we were to look at it on the grid. But as we can see here, going from this dot to here, if we go to the right by 2 spaces, we see that we're going from 200 to 300, right? So the real change in x in this case is actually 100, right? Even though we are going to the right by 2 grid spaces, each grid space in this case is 100, or sorry, each grid here is 50, right? Because we can see here, going from 200 to 300, it takes 2 grid spaces, so which means that this right here is 250. So going from here to here would just be going from 200 to 300, which is 100. And similarly, when we are going up, right, we're going up by 1 grid space, but we notice that going from here to here isn't just 1. Right? We see that this is 80, this is 120, which means that this right here will be 100 on this line. And to go from 100 to 120, we are going up by 20. Right? So our actual slope would be 20 over 100. So that's our slope. 20 over 100. We can reduce that down to 1 over 5. And if we convert that into a decimal, right, 1 over 5 as a decimal is just 0.2. And we notice something interesting here. Right? Given this equation right here, our y-intercept of 60 is just whatever this number is. Right? Whatever the constant number is after our x. And our slope, 0.2, is just whatever this number is right here. Right? That's the number that's associated with the variable. In this case, the distance. Right? So this is actually a rule that will always work. Right? So this is called, or let's do it in some thick pen here. This is what we call the slope-intercept form. Okay? So in the slope-intercept form, it will always be in the case of y equals to a number, x, plus another number. Or I guess it doesn't need to be y and x specifically, it just needs to be a variable, right? And now in this case, in the slope-intercept form, this right here, right, the constant or the number in front of our variable, this is the slope. And this number right here, that's the constant that's been added, that is our y-intercept. Right, so this is what the slope-intercept form is. Again, think of it as y equals to a number, x, plus another number. The number in front of x would be the slope of this given graph, and the number that's been added will be the y-intercept of this graph. Right, so let's go over some exercises or some examples. Okay, so here's what we have. we want to find a slope-intercept form. So we define an equation like this for a graph where it has a slope of -5 and the y-intercept of 5/6. Okay, so once again, we'll drop the slope-intercept form right here. All right, so from the question, we know that the slope is -5. We know the y-intercept is 5/6. Okay, and we also know that in this slope-intercept form, the m is the slope and the b is the y-intercept. Right? So pretty much all we need to do is to plug the numbers in. Right? So as the slope-intercept form of this particular graph, we have y equals to -5x plus 5/6. Right? And that's pretty much it. Right? So this is a really, really nice form for us because it tells us exactly how to make the graph. It tells us where this line touches the y-intercept and what the slope of the line is. And with those two pieces of information, we can pretty much graph any linear relation we want. Right? So we can see in this following example. Right? So once again, this is in our slope-intercept form. Right? So as you can see here, let's do it in green here. So again, slope-intercept form, we can see some parallels, right? We got y right here, we got x right here. We got a number, in this case 1/2 as the m, 3 as the b. And from what we know, this number right here in front of the x, that's the slope. And this number right here is the y-intercept. Okay, so how can we make a graph from here? Okay, so here's what we do. We'll do a little simple graph here. Okay, we got a graph right here. So the y-intercept is 3, which means that in this graph, it will touch this point right here, right? Because that is where 3 is. We got 1's here, 2 is here, and then 3 is right there. And this is the coordinates of 0, 3. So at this point, the graph will touch the y-intercept. Okay? And now the slope. Slope is 1/2. And as we know, slope is rise over run, or the changing y over changing x. Which means that to find our second point, all we have to do is to move. Right? So again, we're moving 1 in the y direction and 2 in the x direction. So to move in the y direction by 1, we go up by 1. And moving the x direction, we go to the right by 2. Right? That's pretty much it. That's our slope, right? Again, slope is 1/2, which is the changing y over the changing x, which means that the y gets changed by +1, the x gets changed by +2. Which means that moving by +1 in the y direction just means going up by 1. Moving 2 in the x direction just means going 2 to the right. Okay? So our second point will be right there. Actually, let's erase this. It will be pretty messy. Right? So again, we go up by 1, go to the right by 2. And that's it. We got 2 points. All I have to do is connect the dots. And I'm realizing just now that my graph is a little too small, but that's okay. Okay, so this is what the graph will look like. And if I really want, I can just extend this line all the way down over there. And just say that's 2 for -2, -4, -6. This line right here will also stretch out to infinity, essentially. Okay, and that's pretty much it. So this is why the slope-intercept form is so powerful. Because literally, all we need is the 2 points, right? We want to know where this line touches the y-axis, and we want to know what the slope is. Once we find that, we get the 2 dots, connect the line, and boom, that's our graph. Right? Nice and simple. So with that being said, here are some practice questions. So toss a bit over here, try those questions out yourselves, and then we'll go over them in a bit. Okay, hope you had some time to try those questions out, right? Especially our word problem here, right? That's a fun one. This is a very common word problem you will see where we actually use the slope-intercept form. But before we get to the fun part, let's do the graphing part. Okay? So we're given this slope-intercept form right here. And as always, we know that this right here is the y-intercept, and this right here is a slope. Okay? So let's draw out our graph here. So we know the y-intercept is at 2, which means that on the y-axis, we have this point right here, right? Because that's where the 2 is. And next, we'll do the slope. So from the slope, we know that is -3/4, which means that we're changing in -3 in the y direction and the +4 in the x direction. Changing by -3 in the y direction just means going down by 3, right? Because remember, in this case, when our changing y was 1, we go up by 1. So in this case now, when we're changing y by -3, we're going down by 3. Okay, so we go 1, 2, 3 right here. That's -3. And then we go to the right by 4. Okay, because that's what the changing x is. So 1, 2, 3, 4. Like that. And we end up having our point right here. Okay, and then from here, all I have to do is to draw a line to connect the two dots and call it a day. So, see, let's do a line right here. Oh, that was pretty good. First try. Let's do a quick adjustment. There we go. So this is what the graph of -3/4x plus 2 looks like. So, again, we're hitting the y-intercept because it's at 2. We're also hitting the slope because we're going down by 3 and to the right by 4. Just like that. Okay, next question. This one's a lot quicker. We're given a slope and a y-intercept. We just have to find the equation for it. Okay, so y equals to mx plus b. Okay, so we know m is -5 because that's the slope. Mx, or -5 x, and the b is the y-intercept, so we have minus -1/2. Alright, that's it. That's a simple. Okay, so now here's a word problem that you'll probably see. So, student console, sponsored Bubble Tea Festival. A ticket costs $5, and the cost for DJ Mr. C, which is me, is $300. I don't DJ, but it'll be fun to DJ at a bubble tea concert or bubble tea festival. But anyways, we want an equation for profit in the P dollars with a sale of tea tickets. So, to start, we start with P equals, right? Because that's our goal. We want to find an equation for the profit P. Okay? And we want the sale of tickets to be T. So the amount of tickets that's sold is T. And because we earned $5 per ticket, that means that the total profit from the tickets will just be 5 times the amount of tickets sold, or 5T. Okay, but we're not done yet. We also have to hire this Mr. C dude who cost $300 for 2 DJ, right? So from our total profit, we have to deduct 300 to hire DJ Mr. C, who doesn't even know how to DJ, right? So that's how we write the equation in something like this. So P is the profit. This is how much money we're making. And to make this much, to make the money in the first place, and now to make this money, first we have to sell each ticket for $5. And we're saying the amount of tickets sold is T. So 5T will be the total amount of money we earn. And then we just subtract away 300 because that is the cost to hire this DJ. Okay? So now, suppose 123 people bought tickets. What is the profit? So now this is where the slope-intercept form is very useful. All we have to do is just to plug in one variable and then figure out from there. Right? So we know, again, P is 5T minus 300. We know that T, in this case, is the amount of tickets sold, and 123 people bought the tickets. So this just means that T equals to 123. And now this just become a regular algebra question, or I guess plugging a calculator kind of question, right? So you got 5 times 123 minus 300 equals to P. So we have 615 minus 300, getting us $315 in profit, right? So assuming 123 people bought the tickets at $5 each, we'll earn $615. But because we have to waste $300 on our DJ Mr. C here, we end up getting $315 in profit. So now, alternatively, we can switch it around. Suppose our profit is $350. How many people bought the tickets? Right? So now in this case, we know what P is, right? P is 350. We want to know how many people bought the tickets, which means that we want to find out what T is. Right? So once again, we just plug it into our formula, or our equation that we derived earlier. So we have 350 equals to 5T minus 300. Okay, so all we're doing is plugging this into that. Okay, we rearrange this equation right here. We add 300 to both sides, netting us 350 equals to 5T. Okay, from there, to isolate the T, we divide both sides by 5. 650 divided by 5 is 130 equals to T, which means that 130 people bought the tickets. Right, so once again, this is why the slope-intercept form is super useful. We just from a simple equation like this, we derive from some information, we can find pretty much anything we want, Or I guess that's related to the question, right? So all we have to remember for this entire lesson is this is our sacred formula for the slope-intercept form. M right here, which is any number in front of the variable, that's a slope, and B, which is the constant, is a y-intercept. Right, I guess in this case, the slope will be 5, right? It just doesn't need to be in front of x. It can be in front of t as well, as long as the number is in front of a variable, right? So in this case, the slope of this equation is 5. We can write that down actually. That's good practice. It's 5, and the y-intercept is negative 300, right? So keep in mind, when we have a negative right here, or a minus sign right here, it means that the y-intercept will be negative. Applying this might take a while because I have to go all the way down to negative 300, well, unless you change the scale. Right? So that's pretty much it. With that being said, keep practicing and stay hydrated.